So between the Giessen KR200 and now, I did have a quick look at the DNT. Mr. Chippie did find a problem, but it's not still working. That's the DNT base station. It's been here ages. Right, so we're going to do this Amstrad 901. This is genuine Japanese one. It uses the connector that's not been available for decades. Wasn't even available at the time, which is why, of course, they had to put the square round one, which is the type we supply. So I'll have to ask the customer whether he wants us to put the square round connector so he can use the set, or whether he has one of those connectors kicking around, which nobody else has, or whether he's just going to use it as a shelf queen, knowing that it actually does work if he had a connector for it. So we'll see what he says. The three types, as you know, there's the square round one, there's another one which is thinner, which you can file out to put the square round in. This one ends up a bit too fat for the square round, so you end up having to put an adapter plate on, which Andrew makes for us, and then we support it because the adapter plate's quite weak. We support that with hot glue on the inside. So we'll see what we've got. If I know we've been given a power lead for these last year, and I still appreciate that. And wouldn't it be wonderful if we could find it? There it is. Aren't many of these around, are there? So at least we can power it up. Right, so we're plugged into the test gear. We'd want to plug in the PA speaker. This radio's also come with the Action Man mic, which we'll eventually look at. Remember, those Action Man mics were withdrawn. If you had one of those and you were disappointed with it, you were able to take it back to your supplier and they gave you a brand new, more normal mic. So there aren't many of those kicking around because people took the opportunity to get a new mic and they never worked properly anyway. So it's alright people saying to me, oh well, if you put a sliver of paper in, right, they were withdrawn, so if you've got one, great, keep it on the shelf but use a normal mic. PA speaker in there. They're there to be looked at, not to be used. Where has that gone? It's there. There we are. So switch the power supply on, 13.8 volts, and on we go. Let's come on channel 20, and put the RF gain up. We'll put the tone to somewhere like that. We'll turn the squelch down, and we'll plug a mic in. So it's a standard Cybernet mic, because they are a Cybernet set. I've got no hissing on receive. Why would that be then? Just see if it works on PA. Testing 1 2, testing 1 2, testing 1 2, testing 1 2. Got a very, very dirty volume control. Not that we have anything still on receive. Right, I'll switch picture in picture on and we'll have a look at transmit. It's doing 1.8 watts. Can't remember how it's spelled. Amstrad CB901 Japan. Now, we've also got a Spinitronic, no, Harvard H646. So if you remember, you've got the Amstrad 901s, then you've got the Hong Kong Amstrad 901s, which on the face of it look genuine, but then Alan Sugar doesn't say in his book, he only goes on about ever having had one batch made, so I don't know. And then you get the fake ones, don't you, which definitely weren't ordered by Amstrad, which were the $29.99 ones. These were the $89.99 ones, and the Hong Kong version with the screen printed circuit board was the $59.99 one, and then you got the fake one, which was $29.99. Well, using that same fake chassis, you got the Spinitronic CB199, which was done for Littlewoods mail order group. Their returns were boxed up and sold on to Harris Overseas, who are Harvard, and they were revamped as Harvard H646s. So there you go. And we've got a Harvard H646 coming from another customer. So when we've done this, if I can do this today, what I'll try and do is the Harvard H646, which is, as I say, the Hong Kong version. We'll try and do that tomorrow, and then we can compare the figures on paper between the genuine article here and the fake of the fakery, and then we can also do the same with the on the air test, so that'll be good fun. Meanwhile, we've got 1.7 watts on channel 20. I think the squelch has issues on this, but that's not unusual on this chassis. Some do, some don't. It's doing 120 milliwatts on channel 40, and on this sounds VCOist, and it's doing 1.5 watts on channel 1. On channel 20, the current consumption is 500 milliamps. Let's go over to low power. We can find a little switch. If you tip it up, it hisses. Good. And on low power, the radio is doing 80 milliwatts. Let's go back to full power. I think this needs a service. Let's look at what frequency it's doing. So we'll go over to camera 2. And it's, well, it's not, is it? It's not happy at all. I can't get a reading until it's transmitting properly. Okay, well, we'll assume that receive is going to be somewhere near 2779. I'll tell you what, we'll guess that it's going to be slightly low, because they're going to be, aren't they? 27, so instead of 79125, we'll drop it a bit. In fact, better idea, we'll set the frequency to the SINAD meter. That's our peak for the SINAD meter is 79153. And so at that frequency, Go over to the SINAD meter. For 10 dB, sorry 12, we've got a really good 0.25 microvolts. Just change scales because that wasn't the ideal scale. 0.21 microvolts. So we're doing this frequency at 27,79153, which is where my test instrument says it's receiving the best. So until we get the transmit working, we won't see what the radio's really on. So for 10 dB, it's 0.2. And unlike that Kerno KR200, this easily does 20 dB, 0.44. Now these may be false figures if the detector's out. Now the squelch isn't right, but then they can be funny. Full squelch never opens, I suspect as much. And minimum squelch, let's do the opposite. I'll put the attenuator on the screen and we're going to park it at 0.3 of a microvolt, switch it to standby, turn the squelch down on the radio, and we can't hear anything because of the squelch problem. This is going to be fun, isn't it? So, guess time. I've got 0.4 for the sensitivity, but I've had to guess the squelch threshold. So when we key up on transmit, it's not happy. And on receive, we put 100 microvolts in on the thing, and it's reading S9 exactly where it should be. So it doesn't have meter lamp. Switches. Check Roger Bleep works. Just turn the volume down so it doesn't annoy people. See what happens on transmit. Put the Roger Bleep on. That was with the Roger Bleep. I can't tell whether that's working. Volume dirty. And PA's working, the sockets are working. Right, well, that's a good start. So we're going to have to go straight for the VCO. Well, there's no shenanigans under there. There we go. It's a nice cobweb. Didn't catch many spiders to eat, did it? Add that to the debris on the floor. Right, we'll move on to the VCO. So if I remember rightly, it's channel 1 on these sets. I'll put it on low power because I think we've got a dirty something. I've cleaned the on and off switch. I ought to spray the volume control as well while I think about it. Might need several applications and quite some wiggling round, but we'll see whether that helps. So meter, we're looking for 1 point something volts, isn't it? 2.2 volts, something like that. Do I need to get the service manual out? No, I've shown it a million times. I also told myself a million times not to exaggerate. So, far side of this capacitor. Well, actually, that's where it should be, about 2 volts. And on transmit is also where it should be. So it's not the VCO. Let's go to channel 40. Yeah, that's about where it should be. So we're not going to. The VCO is fine. Put 2 plus 2. It's fine. And it should, of course, have gone in that box. Right. But I did clean the on and off switch. I felt that was being resistive. And what we're going to do is we're going to prove we've got 13.8 volts going into the radio. So if I go to that on and off switch, and then we're going to transmit. Yeah, still 13 point something, but it's gone full power. 13.5, that's fine. So I've cured that. It was dirty on and off switch, causing us not to have transmit. So you see, I was blaming the VCO because that's the kind of thing it was looking like. So now we can see what frequency it's on, and the radio is actually doing 2.8 watts. So we'll change that to 2.8 watts. Channel 1, 2.8 watts. Channel 40, 2.8 watts. Low power now is going to be better. Well, not a lot better. It's 180 milliwatts. So I can alter that. 180 milliwatts. Back to full power. And our current consumption is 1.13 amps. So 1,130. Frequency, let's go into camera 2, 27,79092. That should have been 053, not 153. Okay. So as the usual thing, if we can't get 3.4 watts, we change the ballast resistor. At least it's in place and the radio's not being thrashed. It's pretty... It's not silly, is it? Nothing seems to be... Let's see where the deviation is thinking about silliness. I know this test set isn't always right. We'll move it on to the other one when we do the deviation properly. But we will have some indication. Wow, it's 4.5 on here, so it is a bit silly. Right, so we'll go through the transmitter. So it's the centre of the peak. Centre of the peak, centre of the peak, See whether that moves or whether it wants a bit of heat. I don't think we're going to get anywhere without changing the ballast resistor. No. So change the ballast resistor we will. Pop the power off. Where's my solder slurper? So these are 3 point something ohms, 3.3 ohms. I'm going to drop it to 3. And we'll increase it to a 7 watt resistor from a 3 watt resistor. So if you think about it, you're not going to get more than 3 watts if there's a 3 watt resistor. It's going to quickly drop off. I have to order these months in advance. So we've got an RS1. So although it's smaller, it's 6 or 7 watts. I've now had these in stock a few weeks and they're getting tarnished. So we'll use the heat shrink. It's not heat shrink, it's Sistoflex heat resistant. There we go. Pop that in, and hopefully Bob will be our uncle, as they say. If you ever see these linked out, I've shown you a million times before what happens, and you end up with the radio doing 7 watts, but it doesn't do 7 watts on 27 megs, it does 2 watts on 27 megs and 5 watts on an aircraft band. So on a cheap meter it looks like it's doing 7 watts, and on a selective expensive meter you find the radio's doing 2 watts. And then you end up being taken away by the Civil Aviation Authority for interrogation. Power back on. Let's see whether we've got an improvement in RF output. Oh yes, we have. Was 3.8 watts at that. Let's make sure these coils are in the right position. I mean, that looks awful, doesn't it? Yeah, you look right, but is this right? What's happened to that? That's not helping it. Okay, we've got 3.8 watts. 2.8, channel 40, 3.8, channel 1, 3.8. Not often this happens. 3.8. Our current consumption now is actually 1.2. 1.219. We've gone from 1.13 to 1.2 for an extra watt. So that's really good. Now, the low pass preset. And it's now doing 210 milliwatts. So that's going to be interesting at scratchy corner, not at scratchy corner, at the 5 mile point, because it's nearly half the power that it ought to be. You could jiggle about with resistors till it's right, but there's no legal reason as to why it needs to be 400 milliwatts these days, so it can stay. I will be checking the underside for dry joints, because I can see there's some moving around when working on it. Channel 20. So let's see what our back from high power to low, back to high power, and we'll do deviation later. I'll do the meter now though. So I want it to read 4 bars. It does. It's making the 5th one glow. Can you see that? I can make it come and go. So I just want it on the edge of that. Then when we're in low power, hopefully it'll read 1, which it does. Remember, when this is on an aerial, it may read 1. When you're in transmit, it might bang across. It'll still be whatever watts it is, 3.8 watts. This doesn't mean you're doing more power. It's only set into a dummy load. This is probably why they've got fake meters on current models, pre-programmed just to show what the CB wants to see. So I don't much prefer it when it was done like this, where it actually samples the RF, but it is subject to it being into a dummy load. So we've done the VCO. We didn't have to do it. It turned out to be spot on. We've done the repair to the on and off switch. We've changed the ballast resistor, got another watt out of it. I think we need to drop the squelch on this before we move any further, and hopefully we can hear something. Might help if I plug that back in. Right, so now we've got the squelch open. Oh, we better put it on frequency, hadn't we? Yes. Let's put the frequency counter up. So 27,79092. As long as I can get it over 100, I'm okay with that. If we can't, we're going to have to start changing the crystal. It will rise a bit more as the test equipment warms up. So we're at 105. 27,79105, and it should be 125. You know, so it's slightly low. Crystal really needs changing. It's not going to be for like another dozen years that it's going to drop below what's usable, so that's fine. Right, back to, we'll put that in on the signal generator, 2779 105. So we're tuning this set to what it's on. We'll put a whacking great big 100 microvolt signal on, and there we go. We'll set the detector. So go over to the oscilloscope on camera 3, do the detector, wherever it's hiding. Hello, where are you? Well out. Now this could be detrimental to the sensitivity. So although we've improved it in one direction, it may have lost sensitivity. Okay, so let's tune it. I think we'll do the IFs first. Let's put that about 12 dB on the SINAD meter. Just get those IFs done, just in case they've been fiddled with. Very slightly out on that one. That's that one. Okay, so now we'll drop the signal to about 4 dB. Put a bit more signal on. And that's it. Let's read off what we've got for our sensitivity now. For 12 dBs we've got 0.22. For 10 dB 0.21. For 20 dB 0.51. So as you can see, they're very slightly inferior to what they were before because the detector was out. But at least it won't be garbled now. So the next thing, these are phenomenal sensitivity. It's hard push to get new sets anywhere near this. See what we can do with the squelch. No, well, we'll do the S meter. So it was right before, but of course I've had to adjust things, so it's now wrong. So we want S9 to be S9 on 100 microvolts. It's not plus 30. So if I move the signal generator up now, I want that to be able to show plus 30, which it isn't doing at the moment. There it is. And where we are at S9. That's great. So we've done that. Roger bleep. I think we could hear that working. Testing 1 2. Yep, it's there. Turn the volume down. That sprays sorted the volume control out in one application, so that's good. So our switches are working. That was done. Ballast resistor 3R7 watt. Squelch. See whether we can get a bit better squelch than what we had. So I'm going to turn the squelch to full. That's a bit noisy as well. So squelch to full. I'd like it to be 100 microvolts. So we'll just step that up a fraction. So now we've got 100 microvolts. I'll show you the attenuator. That's at 0, that's at 100, there's 30, there's 100, and the squelch comes in. So now, when we drop the squelch, we'll turn the signal generator to standby, drop the squelch off, and the radio never hisses. This is one of those, isn't it? This does happen on this chassis. We're going to have to adjust the squelch, I think, so that it opens at this point. Okay, we'll start again. So now we've got the squelch hitting in minimum position, which is how people like it, understandably. Let's see what maximum squelch now is. We have to drop it off. This is all fiddle faddle, isn't it? That's it. So back to 100 microvolts. What a faff. And at the minimum, park the signal generator at 0.3 of a microvolts, turn the squelch down. The set's hissing, which is what people want. Signal generator, squelch to start to threshold. That is threshold. Signal generator back on. And there we come in at 0.3 of a microvolt. Well, that was worth balancing. Now 0.3 microvolts and 100 microvolts there. But on those cheap chassis, which we'll be looking at tomorrow with the Harvard H646 Spinitronic, we'll probably end up having to have the squelch such that it mutes even on minimum squelch, and you have to manipulate the RF gain for it to open. But that's because they're a fake product. So we're done. All we need to do is do the deviation. Into the test set behind me. Drop my glasses on the floor. Wow. Yes, 4.5, so the Marconi test set was reading right today. Wow. That's it. We're done. We'll go back to the Marconi test set. And we'll see what it's decided. Wow. Wrong one. Wow. It says exactly the same, 2.5, so it's working fine today. Right. Well, I'll come back to this when I put it back together. I just want to look for dry joints in the transmitter. There's something which is just making the power change a little bit sometimes, so I'm not surprised. Right, well, we have done the on the air test to this with it in bits. I just want to go through to our base station on the air test with the standard replacement mic. See if we can get anywhere with his Amstrad original mic. I don't want to spend much time on this because they didn't work in the first place, and this is no exception. But I don't know whether it's wired right. You just never know, do you? 40 years, is it 40 years later? It is, isn't it? I've got no receive coming through it. I'm going to have to dismantle both ends. It's all time consuming. Right, so where's our little crib sheet for mics? Right. So I'm doing this on the video. We don't normally do mics, as you know, to check it's wired right. I've had to take both ends apart to prove it. So we can see we've got the indentation there. So look at it from the back. Pin 1, we're looking at Amstrad 901 is configuration 1 on this sheet. So 1, 2, 3, 4. So pin 1 is white, pin 2 is the braid, and that's correct because it's the braid. Pin 3 is supposed to be receive, and pin 4 is supposed to be transmit. And that all looks what you'd expect. So we look at this end and see whether the colours all match up. So white was the audio, so it goes to the mic, because you've got a 2-pole switch here, 2-pole changeover. So the mic element goes in on the red wire and comes out when you press the switch on the white wire, which is the screened one. Our receive one is on the normally closed position, and our red wire is on the normally open transmission position. So it's absolutely wired correctly. So all I can do is put some switch cleaner in the hope, but it wasn't even receiving with this mic connected. We'll just try and work that in. So I say again, these were withdrawn, you got a free replacement. So that's it. So it is wired right, and if it doesn't work, well, it doesn't work. So put it back together. He sent quite a few different mics, and we'll see what works with what. We did the on-the-air test sooner rather than later because it made it that the on-the-air test was still light. Right, so plug it in the radio. We now have receive, which we didn't have before. But not for long. See whether it's a break in the lead or just still dirty contact. We'll just try another spray bit from this side this time. Turn the radio off because I obviously don't want to keep switching it between transmit and receive on. It's supposed to be self-wiping contacts, but there you go. Switch it back on. does something, doesn't it? It'll be 20 minutes to fix the radio, to tune the radio, and 20 minutes to fix this mic, and then find it still doesn't work. Testing 1 2, testing 1 2, 1 2 1 2, 1 2 1 2. If you squeeze it hard, of course, it does work a bit. Well, and we'll try it through to the base station, but that's today's freebie. I'm not going to put the screws in the case. Perhaps the customer, if he sees this video, will say, yeah, send it back as it is with the original power connector, or just do what you can with a different connector. So there's the rest of that cobweb up there. But he's got a bit of time because we've still got his binatone to do. Anyway, that works very nicely. I'm just going to do some dry joints bit off camera. Just some potential ones there. Just where it gets hot. So I'll leave the screws out. And we'll do our final bit to see if there's anybody out there on with our mic. One down to Roger. Wonder how many watts he's doing. So there we go. Amstrad 901 from 1981, the genuine Cybernet 002F article, not the fake one. Thank you for watching.